Welcome to Unit 1, Lesson 5, Key Features of Quadratics. So in this unit, we're going to talk about, or this lesson, we're going to kind of take everything we've learned and we're going to put it all in one. That is the goal here. So we want to compare and contrast a function from a graph, table, or equation to determine similarities and differences using language of compare and contrast. So you have some language terms here. The compare and contrast will happen under summarize. It will not happen today in this lesson, but it will happen in the summarization. So right now we have a quadratic function here. I know it's a quadratic because it has this nifty power of 2 that always tells me I have a quadratic, and I'm in the standard form, right? The ax squared plus bx plus c. So I know what I'm going to have to do. Now, x-intercepts, where do they happen? Well, they happen when your f of x is equal to 0. Well, here's my f of x, right? Also known as our y, so let's make that 0. It's x squared minus x minus 2. So now we're going to do the AC. So A1 times -2 is -2. We're going to find the two numbers that add to my B, which is a -1. Because there's no number here, that's a ninja 1. So two numbers that multiply to 2 and add to -1. Well, 2 only has one set of factors, which is 1 times 2. So now I just got to figure out which one's negative and which one's positive here, because the only way to get a negative number in multiplication is to have one negative and one positive. So 1 times 2. Well, I can see that this one is also negative, so therefore I know my bigger number is the negative. Had this been positive and this negative, then I would have known my bigger number is positive. Now, because I don't have an a greater than 1, I can go ahead and throw them right in my parentheses. I don't have to do the separation step. So just go right here, -2 and x equals 1. Or I'm sorry, plus 1. That's a plus, I swear. All right, equals 0. Now, using zero product property, I can separate these because if I have something times something and it equals 0, something there is 0. So therefore, I can say x minus 2 equals 0 or x plus 1 equals 0. And just simply solve these like, our basic equations. So I can say x equals 2 or x equals -1. So therefore, my two x-intercepts are 2, 0, right? Because I inputted 0. I'm sorry, my output is 0, right? My output is 0 in this case. And then I got a 2, or I have -1, 0. So these will be my two x-intercepts. It's one of my key features. There's lots of them, but this is just one. All right, so let's move on to the next one, which is our y-intercept. And our y-intercept happens when our x is 0. That is noted with the inside the parentheses. That means I'm just going to substitute in my x's, right? So now I have 0 squared minus 0 minus 2. So this is 0, this is 0. Now I'm just left with a -2. So in this case, my y-intercept, I inputted 0 and I outputted -2. Right? I put in a 0, I got out a -2. So here's my y-intercept. All right, our next key feature, I call this AOS, but this is the axis of symmetry, okay? Axis of symmetry. Now, the axis of symmetry can be found using the formula -b divided by 2 times a. Okay? So here we are in my A, B, C. Okay, here's A, B, C. And what I'm going to do is I'm going to substitute those numbers. So I have a -1. So negative is positive, right? And then 2 times whatever's here, which is a 1. Remember, I always put these in parentheses when they're next to a number. That denotes multiplication. So now I have 1 divided by 2 times 1, or 1 divided by 2, right? So I can call it 1/2. Or if I hate fractions, I'm going to call it 0.5. So my axis of symmetry, which is a straight up and down vertical line, which is x equals -5. All right, so my next thing is vertex, and vertex happens at the point of my axis of symmetry. So I know my x is going to be 0.5 because that's what I found in my last one. So I'm going to input this in, right, in my input zone right here, 0.5 squared minus 0.5 minus 2. Okay, and I'm going to use a calculator because I don't know about you, but I don't know what 0.5 squared is. So I'm going to put 0.5 times 0.5 and get 0.25 minus 0.5 minus 2. And I'm going to start right from the left to the right on this, okay? From the left to right. So I'm going to minus 0.5, and I'm going to get negative 0.25, and then I'm going to minus 2 more. I'm going to get negative 2.25. So my vertex happens at my axis of symmetry, comma, what the y value is. So I input my axis of symmetry, I get my output. So I have 0.5, comma, negative 2.25. All right. So this is the bulk of them. Now, they're easiest to look at and find over here on the graph. Okay, so I'm going to label some points here. So here we go. We have an x-intercept, right, which was negative 1 comma 0. We had another one over here, which is 2 comma 0. All right, and then we have a y-intercept right here, right? I know it's my y-intercept's the y-axis, which was 0 comma negative 2. All right, and then we have this, my vertex down here, and it was easier to find because this doesn't look that easy to find. And that was 0.5 comma negative 2.25. All right, now we also have our um, axis of symmetry, which was at 0.5. So it's just this little line that goes right here. And this little line just shows me simply if I cut my function in half right here and folded the paper from this side to this side, it would sit right on top. All right, but I still have a couple things that are easiest identified from the graph. And first is domain, okay? All right, so let's look left, and we can see that this is not a point, right? So we call it an arrow. So we know it's going to go on forever that way. Now look to the right, and we see this one, right? So we're going to point it that way, and we know it goes on forever. In fact, every quadratic has the same domain that you're ever going to run to, and that domain is negative infinity less than x less than positive infinity. That's every quadratic, okay? Every single quadratic. In fact, it's every polynomial, which we'll get into in Unit 7. But for now, know that the domain of every quadratic is the same. It is negative infinity, positive infinity, or you can call it all real numbers, same thing. Now range. Range is read from bottom to top. So we know the bottommost point right here at the vertex, right? So that is a point. However, here we can see that there's no point. These kind of go on forever, so we'll give it an arrow. Okay? So down here at this bound point is actually the y coordinate of my vertex. So we're going to say negative 2.25 less than y. Oh, included, right? Included, that dot's included. It is part of the line. Less than positive infinity. All right, so now I've mastered domain and range, and I still have one little kind of thing I have to do here. And that last thing is they always ask me, is my quadratic have a minimum or a maximum? Well, in this case, because it's at the bottom, right, and it opens upward, I can say that this function or f of x, you can call it this f of x, has a minimum opening upward. All right, and bam, those are all of my key features that I need to be able to identify. And once I can identify, then I can make statements of comparing and contrasting, right? One of those statements I'm always going to have for every quadratic, and this is an example of what you're going to do in your summaries, is I can talk about domain, right? And I can say the domain, and you'll have two functions, right? So the domain of, say, one is f of x and g of x, right? They have these cool names, g of x and f of x, same thing, just two different functions, right? If I just said y equals all the time, you wouldn't know which one I'm talking about. So he's given these little names, they're still y. So the domain of f of x and g of x are the same. At, right? We want to give this concrete information, guys. This is really important that you are putting this into your statements. Okay, one, it tells me what it is, the domain of the two functions, tells me if they're same or different, right? In this case, the same. And lastly, you give me the valid information. So you give me the point, you give me the actual domain. And this needs to be written in all your sentences like this. So, all right, go off and head to your Explorer.